Good afternoon. I'm Nancy Edwards, curator of European art at the Kimbell, and it's my great honor to introduce our speakers today. Frank Sherwood, who worked for the firm Preston M. Guerin and served as project director for the Kimbell, and Larry Eubank, the Kimbell's operations manager, who as a young man worked on the construction of the building. I know that everyone in this auditorium is well aware of the magic of the Kahn building. Just this past week, I was stopped twice when I was going into the office area by visitors who said, great job, meaning I've got a great job. And at first I thought, oh, how do you know that? And also, you are so lucky to work here every day. And those of us who do work in the Kahn building feel that magic. And our speakers today have a truly intimate understanding of that magic, and they're going to help to deconstruct it, so to speak, and make us appreciate it all the more. Frank Sherwood, who is a fellow of the American Society of Civil Engineers, has some 70, but who's counting, years of experience in design, construction, and administration of building projects. He began his career with Fort Worth firm Thomas S. Byrne, working on various projects in Texas as engineer, project manager, and vice president. In the 60s, he served as senior project engineer and later director of facilities construction and design with American Airlines, relocating to Los Angeles and later New York. He returned to Fort Worth in 1966, and from 69 to 86, he worked for the firm Preston M. Guerin, holding multiple positions, including executive vice president. In addition to serving as project director for the Kimbell, he was the firm's principal representative for the original DFW International Airport passenger terminal design and construction, and project director for a multitude of subsequent projects at the airport. He was also project director for Cook Children's Medical Center, Fort Worth, in coordination with the architect David M. Schwartz. There's so much more that I could say, but we're anxious to hear from our speakers today. And I'd just like to repeat some remarks that were made when Frank was given honorary membership in the Texas Society of Architects. They said he is an engineer with the soul of an architect. Sherwood has been a key figure influencing the creation of Fort Worth's most significant architecture, most often by cultivating relationships between influential clients and notable architects. I'd like to also mention his very generous community service, because he has served as a president or board member for many Fort Worth institutions, including the Symphony Orchestra Association, the Kiwanis Club, at Cook's Children's Medical Center, and so on. And next, Larry Eubank. In his 40 years at the Kimbell, Larry has played a role in all of the museum's architectural achievements. As the Kimbell's operations manager, he collaborated with Pritzker Prize-winning architect Renzo Piano and the international team of professionals that were charged to develop the critically acclaimed Renzo Piano Pavilion, which opened in 2013 and whose beautiful auditorium we're enjoying today. As well, Larry has coordinated multi-million-dollar renovation and infrastructure upgrades to the Kahn building. These ongoing improvements have improved the efficiency and the decreased energy consumption, while always maintaining the architectural integrity of the original structure. In addition to overseeing the daily operations on the Kimbell campus, Larry collaborates on the design and installation of permanent collection objects as well as exhibition displays. Last September, at the J. Paul Getty Museum in Los Angeles, Larry received the prestigious 2018 Lifetime Achievement Award from the International Association of Museum Facilities Administrators. This award is presented to an individual who's made exceptional contributions to the state of design, construction, operations, and/or maintenance of cultural facilities, and so well-deserved. As is Frank, Larry is a generous volunteer who's served in prominent roles in his hometown of Weatherford and in Fort Worth, as well as national organizations, including, he was a co-founder of the Fort Worth Cultural District Facilities Council and became its first president, a role he holds again today. He is also past president of the International Facility Management Association, and organization he also continues to serve. So finally, we look forward to hearing these gentlemen speak, and a warm round of applause for them.
Thank you, Nancy. We have a couple of people we'd like to recognize before we get started here. Frank?
First, we'd like to recognize the then young architect working for Preston Guerin, who manually developed virtually all of the exquisite architectural drawings for the Kimbell. He's architect Dwayne Manning and his wife Cynthia from Tyler, Texas. Stand up. And I regret our other architect involved, Terry Garrett, is not here today, but I want to mention his name. He did all the site work drawings for the Kahn building. Next, Shelley Seymour Kennedy, daughter of the late Tom Seymour, who is project manager for Thomas S. Byrne, builder of the Kahn Kimbell Museum. As you know, the title of this presentation is Constructing the Kimbell, an Eyewitness Account. We surmise that all or most of you are here because you're aware that the Kimbell Kahn building is widely acknowledged as one of the finest art museums in the world, due principally to the design of the building, which successfully integrates natural light in its galleries. This is due to original museum director Rick Brown's vision that while most museums of the 1970s were designed with windowless galleries, white walls, and incandescent lights, natural light's far superior for illumination of the artwork. Brown's collaboration with Lou Kahn resulted in the design of the cycloid galleries with central skylights and the very effective perforated light reflectors. In this presentation, as the title states, however, we will focus on not the design, but on the complex challenges required for the museum's construction.
Just a little comment about myself here. I first showed up on the construction site in the summer of 1970 and went to work for Thomas S. Byrne Company as a carpenter's helper and worked on the construction project up to February of 1972. Then E.B. Brown, who was the project manager or owner's rep then, hired me on March 20th, 1972 to be his assistant building manager, to learn from him and to take his place eventually, which I did in '85 when he retired. And I later became building superintendent and then now currently the operations manager. And just wanted to recognize also a couple of people. We have Kimbell Wynn from the foundation and Ben Fortson, and then our director, Eric Lee. And just to give a little bit of kudos to the people that started this place. The origin of the Kimbell Art Museum lay in the desire of its founder, Kay Kimbell to have a public place to properly display his art collection. He and his wife Velma grew up and were married in Whitewright, Texas. Mr. Kimbell was a self-made entrepreneur who started work at the age of 13 in his father's grain mill. He grew his businesses into more than 70 companies. They moved to Fort Worth in 1924 and started collecting art after visiting a show at the Fort Worth Public Library in 1931. At his death in April of 1964, they had collected more than 360 art objects. In his will, he donated his estate to the Kimbell Art Foundation, except for provisions to provide for his wife. Within a few months, she donated her part of the estate to the foundation to carry out his wish to establish a museum of the first class. The board of the Kimbell Art Foundation at that point was A.L. Scott, Velma Kimbell, Dr. Carter, K. Carter Fortson, Ben Fortson, C. Brinkley Smith, Philip A. Norris, and Benjamin A. Bird. That started the wheels in motion by selecting the site. Dr. Brown was selected as the director, and he told the story about being contacted about this new museum in Texas that they wanted him to come and be director of. And he said he first thought it was some basket weaving society, and that you know, he kind of pushed it off. And then finally some of his friends said, hey, you know, this is the real deal. You need to come take a look at it. And of course it did happen, and he was hired as the director.
Well, and when Rick Brown then came to Fort Worth and began to try to choose an architect for the Kimbell, he considered a great number of them. I can't list them all, but Mies van der Rohe was one, Garden Bunshaft was another, and of course Lou Kahn. And from that very outstanding group of architects, he did select Lou Kahn. This photo brings to mind a little-known event affecting the Kahn building site. One day in the 1960s, probably 1962, following the opening of the Amon Carter Museum in 1961, oilman Tex Moncrief Jr. was driving from his Arlington Heights residence down Camp Bowie Boulevard to his office in downtown Fort Worth and noticed a bulldozer excavating at that site. The corner of Arch Adams, now Van Clymer Way, and Camp Bowie. Curious about this, he called City Hall and asked what it would cost to, what the excavation was for, and was told it was for a new city-county health services building. Tex was smart enough to realize that that was an inappropriate site for that kind of a building within the cultural district, and he said, then he asked the city how much would it cost to relocate the project, and was told it would be $60,000. Tex then called his father, W.A. Moncrief Sr., who was vacationing in La Jolla, California, described the situation and asked if Mr. Moncrief would contribute $30,000 for the restoration if Tex could persuade Amon Carter Sr. and Sid Richardson to contribute the like amounts. Mr. Moncrief agreed, and Tex called Mr. Carter and Mr. Richardson, who agreed to provide matching funds, and thus the site was saved to be vitally important part of the city's cultural district.
Moving on to the groundbreaking, it was on June 20th, 1969, the ground was broken for the construction project. J.C. Pace was at the lectern there. He was the chairman of the foundation, and then Velma Kimbell here to the left, J.C. Pace, and K. Fortson, Dr. Brown, and Preston Guerin Sr. This is the model of previous to the building itself. We don't really have a model of the building. This was the largest, or a larger model than what we had, what the building was constructed. It was 450 feet long. There were 19 cycloids, I think, instead of the 16. It was considered too large to, we didn't have enough artwork to fill it, so it was decided to cut back the size of it. So there was a cycloid removed from each section, each end, and one in the middle, and we ended up with the 16 cycloids that we currently have. The reflecting pools were in, and then placed in front of each wing at the ends.
This is an example of Dwayne Manning's superb drawings for the Kimbell. As you can see, he did this in exquisite detail, and it was all done manually, no computers, no automatic machines, but absolutely beautiful drawings. Preston Guerin Jr. bequeathed these drawings to the architectural libraries of the University of Texas at Austin, although Preston himself was an absolutely outstanding Aggie.
In May of 1969, the contract was signed for the construction of the building. Tom Seymour here, and Thomas S. Byrne Company, A.L. Scott, Lou Kahn, Dr. Brown, and Preston Guerin Sr. And then construction was began with the drilling of the pier holes on the south end of the site, going down approximately 23 feet to the rock structure below to support the building above. This is a basement floor poured with the columns reaching up toward the first floor level. In the foreground here is the block out for the freight elevator. And this is the basement, or the first floor level with the pan job. You can see the metal pans out here that created a waffle slab in the construction of the first floor. And then the rebar would continue on up to for columns and then to support the cycloids further in the project.
This is a photograph of Rick Brown and Lou Kahn in the construction shack looking over plans. And I think it's typical of Rick's interest himself as the owner working with the architect, which is not always the case, and shows their very close relationship.
This is Tom Seymour and Dr. August Commandant, structural engineer, and Guy Austin, site supervisor for Guerin. Here, Tom Seymour and Lou Kahn are signing sample wall number 5 on, this was December 22nd, 1969. It was a mock-up of the wall with the right color of concrete and all the details that would go on to form the other walls and stuff. So that was the selection process. So this is Tom Seymour and Dr. Commandant again. Frank,
Dr. Commandant was one of the most outstanding engineers in this country. He was, interestingly, was born in Estonia, as was Lou Kahn, and he, due to an absolutely accurate story, during World War II, General George Patton was needed to cross a bridge somewhere in Europe, and he found Commandant and asked him to figure out what areas of the bridge would support his tanks. And Dr. Commandant, this is an unbelievably true story, got a paintbrush and painted a white line on the bridge where the tanks could cross. He's due much credit for the Kimbell Museum. His pre-stressed concrete designs are just outstanding.
And curiously enough, his son is a structural engineer too, and in January he came to visit his father's building that he worked on here, and I gave him a tour of that jury commandant. He was very pleased to see his father's work, and I think he actually was in his office at some point in time, and Dr. Commandant gave him some little problem to work on and to figure out. These are this is the floor of the gallery floor over the east entrance, and the styrofoam blocks that you see here were used to reduce the weight of the concrete. They were 8 inches by 30 by 30, and there were 2,600 of those put into the gallery level slab. The blockouts you see here for the recessed lights in the east entrance, and then concrete would be poured about 4 inches thick on the bottom forms, and then the styrofoam would be put on top of that, and with the spacings you see between them, and then the wire mesh on top of that, and then they would come back and fill in the voids in between the blocks, and then pour another 4 inches on top of that. So the slab itself is a total of 16 inches thick. So the ceiling below and is the same as the floor above, so it was just one solid piece.
Well, and it was interesting when the workmen were concerned about how they would keep these styrofoam blocks in place. Once you put that block on wet concrete, the capillary action just like gluing it together.
There was some, with the wire mesh over there, we made some little staples that we'd put down in the wire mesh that would stick into the styrofoam too, and then help hold them in place from moving side to side a little bit. Made a lot of those. And then also, let me back up one here. Also, the floor, the gallery level floor, has post-tensioning cables in that as well, running east to west, and especially to support the floor over the east entrance. Here is a shot of the east wall of the library. It'll be the furthest east wall above the east entranceway. And you can see in there the post-tensioning cables there, starting at one end, dipping down to the middle, and up on the other end. It's almost like a suspension bridge. And you can see how many cables there are. There's probably about 7 cables in there. Each one of the cables is, there's 20 quarter-inch steel rods in there, and they're enclosed in a tube to keep the concrete out of them. And then those are cast into the wall, and then later, when the concrete is set up to 75% of its design strength, the hydraulic jacks are put onto the cables and stretched to give them the tensioning. This is another picture of the cables in another wall. This would be on the west side above the offices where there's glass below, and it helps support that exterior wall. This shows the hydraulic jack attached to the cables, and they're putting the tension on that.
This is an illustration of the typical wall construction, which shows the farm tie holes that were filled with lead plugs. And when the first pours were made, there was some leakage of the water in the concrete around those farm ties, and Superintendent Virgil Arp figured out to use some neoprene washers to minimize that leakage, so that you can see it turned out to be very precise.
And the cavities where the wall ties were, the wall ties helped the forms together, and then when the forms were wrecked away, the wall ties were snapped off, and it left a cone-shaped hole there. Those, I got the distinct pleasure to fill those. And when we first started out trying to find a way to fill them, Virgil Arp gave me some lead wool and a hammer and a tool and said, here, fill these holes with it. Well, it took me about 30 minutes for one hole, and they decided that wasn't cost effective, so we ended up making a little lead plug. It was about 1 inch in diameter and had tapered sides, and I poured up about 1,500 pounds of lead to make those lead plugs, and then I put about 95% of them in. So, also, the little V grooves you see on the forms, if you look around the exterior of the building, you'll see that pattern. It was difficult to wreck the forms off without breaking some of those little V grooves off, and you know, and they wanted to go in and patch them, and Kahn said no. What was the comment?
Well, Virgil Arp apologized to Mr. Kahn and said, Mr. Kahn, I'm very sorry, but there's no way I can wreck these forms without breaking off some of these little fins. And Lou Kahn says, don't worry about it. He says, when Michelangelo drew a straight line, it was not perfect. It had some irregularities.
And this is a drawing out of Dr. Commandant's book, just showing the top. You'll see here the post-tensioning cables coming down and then to the middle of the cycloid, then they go up on the other end. And also a detail of the vault itself and the beams. So this, we have a copy of his book here. It's 18 years with architect Louis Kahn. This has some interesting stories in it if you get a chance to more something to read. And this, Dr. Commandant did all the structural calculations for the cycloids, and this shows all of his work was done by hand, and I have the booklets here that, you know, this was back in '69, and you know, there was no computer stuff done with it. It's all hand done, and it's just, I mean, it's just beautiful. I mean, his drawings and his writing as well. And curiously, I picked out one of those in there that says, well, this is wind loading on cycloids and then tornado pressure distribution. So I'm glad he considered those things, especially today. We may have some wind and stuff. So, okay, a mock-up was poured on the site to work out the details of the various aspects of it. Frank?
Well, this was, many things were done to be sure that the contractor was going to complete the building in accordance with what Lou Kahn wanted. So this shows how the travertine was to be installed on the ends of the cycloids, the shape of the cycloid end beams, and the glass inserts, it's called lunettes, between the solid wall and the beams, and then the lead roofing and the skylights and the edge gutter of the cycloids.
Okay, on site, this was a jig that was set up to make ribs, which was basically just two 1x4s that were saw kerfed and then bolted together in the shape of the cycloid. Those were to be installed in the forms later on. In the next couple of slides, you'll see that. And then also in the background there, you can see this is the rebar for the end beams of the cycloid. Those put together on the ground and then lifted up into the forms on the roof. And then also back here, you can see some of the post-tensioning cables coiled up there waiting to be installed. This is also cycloid forms. These were made and stored in waiting, getting ready to be put together to actually form the support for the cycloids. And here, this shows the soffit area. This is actually a flat slab, Frank.
Well, it's inverted, sort of U-slab, because it had space between those two edge beams for the mechanical and electrical elements. for the galleries.
This was poured first, and you can see the shoring here underneath it. That would remain until the cycloids will be poured. The cycloid actually supports this soffit beam. You can see here above the beam there, rebar that will be later tied into the cycloids. And also in the background, you can see various other forms going up for the end of the cycloids and other areas. This is, again, those components that we're laying on the slab there have been brought up to the roof and pieced together, and then plywood added on top of those to form the base for the concrete to be poured on. Again, the rebar there will be tied into that cycloid. Another shot of it here showing the opening for the skylights, and iron workers are installing wire mesh in it. They're putting chairs down, and then the wire mesh goes on that. It's actually to hold the steel and rebar up off of the forms. And then this is the post-tensioning cables. After the rebar and wire mesh would go in on the bottom, and then the rebars go in, and then another layer of wire mesh and some more rebar on top of that. You can see them here again, the cables starting at the ends and drooping down to the middle, and then would go back up on the other end. The ribs I mentioned before, that's these here. They're being placed on the forms for the cycloid. They will stay in you can see little bolts here, if maybe it's kind of hard to see them, but they would be down into the concrete, and that would hold the ribs in place and have various functions after the cycloid is poured. Here you can see one complete cycloid, 100 feet long, that's ready to be poured in concrete. You can see the ribs in place, the steel and rebar, the post-tensioning cables down below, and then the blockout for the skylights up here. Here you can see one that has already been poured, the opening for the skylight, and there's also cross beams every 10 foot in the opening of the skylights. That's to keep the vaults from actually collapsing on themselves because of the upward force. And then you can see the ribs here, and then where insulation will be put. Here is actually pouring the cycloid. Back then, most of the concrete was poured with buckets hoisted by cranes. You can see one here and one in the background. It took approximately 4 hours to pour one cycloid. Today, that would have probably been pumped with a concrete pump instead of using the buckets. You want to talk about that?
Here you can see the carpenters applying these little planks of 2x6s with little nailers, because at the bottom part of the cycloids, the slope of the cycloid was such that the concrete had to be contained with an outer form. So the contractor devised this method of making that temporary outer form until the pouring got up to a point on the cycloid where it would contain itself.
And those were removed and reused, cleaned up, and then recycled after each pour. Here's one just actually showing the concrete being poured in there with the vibrator, and then actually the blocks in place doing their job. Finished product, again, here is the ribs that stay in there. The area in between will hold the insulation. And then you can see various stages of other vaults here. This one here is ready to be poured. This one is completed, and this one's completed. Again, once the cycloids had set up and the concrete had reached it's 75% design strength. The hydraulic jacks were applied to the post-tensioning cables. Here you can see the jack attached to it and the pressure gauge here. I believe 120,000 PSI was applied to the cables. Here you can see where the collar on the cable has been tensioned and pulled out. And then here is a steel block that was placed under the collar, between the collar and the concrete shell there, and that was to hold it out, hold the tensioning on it. And then later, after all of this was done, we would come back and fill in this void with concrete. You can look at the end of the buildings and see the little blockouts. There's a little groove around the where these were filled back in, and you can see those. Here, insulation is going in between the ribs. Here, after the insulation comes the decking, 2 layers of 3/8 plywood with staggered seams, glue joints to hold it down. My father was a carpenter on the project, and this is actually him right there installing the decking. He worked for Burns for about 30 years or more. So there, the lead roof is going on over the felt paper. And there's a good story about the lead. Kahn originally specified lead-coated copper for the project. And when Dr. Brown saw the finish on lead-coated copper, which was very shiny, he says, "You're not putting that on my building for 1 minute." And they told him, he says, "Well, it'll oxidize and patina out to a dull gray finish." And they even showed him a steeple in what church was it?
Broadway Baptist Church downtown.
That had patinaed out to the oxidized to the dull gray finish. He said, "You're not putting that on my building for 1 minute." And it seems that lead was a little cheaper than copper at that point in time, so they made a decision to cancel a contract with Revere Copper Works for the lead-coated copper, and then they selected calcium lead as the lead to be put on the building at 2 pounds per square foot. I have a letter in the file from the president of Revere Copper Works who, when they canceled the contract, he sent a letter out saying this calcium lead is an unproven roofing technique, and basically, you know, it's kind of a sour grape deal, but he said, "You'll be sorry." So
Yeah, he said, "I cannot possibly understand how you would cover valuable works of art with something like lead when lead-coated copper is what you ought to use."
So anyway, so here's the finished product with the first roof. Turns out he was right. We had some problems with the lead. You can see here in the foreground some dark roofing asphalt that was applied over holes. I started finding holes in it as early as 1976. It was a galvanic reaction coming from underneath. The lead was put on with copper clips, and it was just corroding and eating the lead away. And we eventually changed the roof out in 1986. At that point in time, there were about 75% of the sheets had holes in them. We then went to a chemical lead. Frank was involved with us on doing that roof. We increased the thickness of the lead to 2 pounds per square foot, and incidentally, we checked the structural integrity and to see that the cycloids would hold up that additional weight, and it would. So this was called chemical lead, and panels were basically around 2 foot wide and 5 foot long, and then 5 foot long on the horizontals as well. And that roof performed very well. And during the process of acquiring the lead and stuff for that, we had let me back up a second. We had a lifetime warranty on the lead, the original roof, from RSR Corporation in Dallas. And a phone call I made talking to a guy at RSR about the lifetime warranty was pretty interesting. And he kind of directed me to the salesman that had sold that instead of taking the responsibility for it. But anyway, they paid for the pound for pound for lead to replace it. Then we had a little thing happen in '95 called a hailstorm on that roof, and we had hail up to, you can see there with the tape measure, up to about 3.5 inch diameter.
Some of you may remember that was during the Mayfest. It was a horrible hailstorm, much damage, even some serious personal injuries.
And if you were here and had a car, you probably had damage from it too. So, and then in the process of replacing that, we had got an insurance claim on that, of course, and we started looking at the replacement for it, and it was decided to try to go back to the lead-coated copper that Kahn had originally specified. So that was the direction we worked to get that done, and we did actually put the lead-coated copper on it. And you can see this is kind of why Dr. Brown had objected to it, the shininess of it. We had 20-ounce lead-coated copper, and that's what's on the roof today. It did actually patina out and oxidize to the gray, dull gray finish that Dr. Brown and Kahn wanted. So, okay, this is the underneath side of back to the construction project. This is back with the forms being wrecked out underneath the cycloid. And Frank has some good story about that.
Well, one of the most ingenious things done by the building contractor, Thomas Byrne, was the development of how these farms could be built so that they could drop down, rotate, as you can see, and then pass under the beams, the upside down beams housing the mechanical elements between the slabs. And that development was done by one of Byrne's carpenter foremans, Buck Shaw, and his grandson, Bart Shaw, architect, is in the audience today. Anyway, it was a phenomenal bit of ingenuity from not a technically educated man, but a fellow who understood how to do things.
Let me just say a little bit here. And when the forms were removed and the concrete had set up and the forms were dropped down, well, let me back up. In prepping the forms for the concrete to be poured on them, we coated the forms with a polyurethane coating and to give it a slick finish. And there was a lot of work went into making the forms smooth and no holes in them, not like your normal concrete job, form job. And you know, trim hammers were used on it, and the carpenters commented on that about having to use a first form job they'd use trim hammers on. And anyway, and once the forms were all set and ready to pour, we spent a lot of time blowing all the dirt and stuff out of them to get everything, you know, as clean as we could. And then in wrecking it off, the polyurethane coating would sometimes hang to the vault. And we spent a lot of time cleaning that off and took just vibrating sanders. And one of the things I did too in there was going in and vibrating that off and cleaning it up. Then here, I think, you know, and what Frank was talking about in the way the forms pivoted down, you can see right here at this point is the pivot point for the forms, and then they were let down and then rolled from one spot to another. I think there was a total of 3 sets of the forms built, enough for a 100-foot section, 300-foot sections.
Well, and you have to realize that if Buck Shaw hadn't figured out this system, it would have been necessary to build those farms rigidly, then sort of tear them all down and then rebuild them for the next cycloid. So it was much more efficient done this way.
Yeah, these were about 20-foot long sections, and they would let them down like this, and then we had some jacks and things to put under where it'd be rolled over to the next site to be set up for the next cycloid.
Yeah, again, I kind of laugh about this. Mr. Shaw went down to Montgomery Wards and bought some automobile jacks to do that raising and lowering of the farms.
Here is one of the sets of forms that's being lifted by crane. This would be for the north portico of the building, so they couldn't roll the forms out there so they had to erect them on site and then lift them up. Here is a meeting of the minds in the staff parking lot. You can see Dr. Brown, Virgil Arp in the background, Guy Austin with Garen, Lou Kahn, Tom Seymour, and Frank Sherwood here. Do you remember what you were discussing there, Frank?
No, it must have been important.
In the background, you can see the opening for the loading dock door there behind Dr. Brown. Here, just an aerial shot showing some of the cycloids that have been poured. They've got tar paper on them waiting for the lead roof to go on. Speaking of the lead roof again, McClung Roofing did the roof project, and they actually set a little shop up on the roof with brakes to make the joint seams for the lead roof. And here you can see some that are waiting to be poured, and then two more here in the middle that haven't been formed up yet. Also in the spot out here to the left corner, this is the utility vault where we have the transformer, pool pumps for the reflecting pools here that are not in place yet either. And later the cooling tower would go out here in the upper area there. This is showing two cycloids with the upset U-beam with nothing else in it. You can see here at the far end where the ductwork for the air conditioning is coming up here. The electrical would also come into that space, and then you can see there all of the scaffolding and support structures have been removed, and the cycloids are actually holding that up, supporting it. And then after all the ductwork and electrical is in, aluminum panels will be placed over this to cover that ductwork and electrical. And then you also see the opening for the skylights with the light coming in. And here's the start of the light diffusers, the hangers for those. You can see every 10 foot there's a concrete beam between each sides of the vault, and then these little support structures to hold up the diffuser. And this is an aluminum diffuser. Again, each section is 10 foot. This is a perforated aluminum. And there was a lot of trial and error, as I recall. Richard Kelly was the lighting designer. And Frank, I remember on the construction site, there were the little short sections of the cycloids. They would put up a couple of these and put black plastic down to see what the light did as it come in, and a lot of trial and error on these. And in terms of the frequency of the holes in the aluminum, the diameter of the holes, and also the thickness of the metal.
That was an extremely complicated process to reach the right conclusion of the size of the little bitty holes and the reflectance of the aluminum. The surface called an Alzac surface, which is the same thing that old photography flash bulb holders used to have. But anyway, Richard Kelly allegedly used, to our knowledge, the only computer work done on the Kahn building was that Kelly used a computer to develop the shape of those reflectors, because it was sort of an inverse, if you will, of the shape of the cycloid. If you can imagine these upside down, one half of them is sort of like half a cycloid. Then
This previous slide is in a non-gallery area. There's a solid piece of metal at the very apex top of the diffuser, and in non-art areas it's about 6 inches long. In art areas it's about 18 inches long, I think, and then Frank had some input into that.
Well, that came to pass because one day before, when they were all solid perforated sheets, Rick Brown noticed that at certain times of day the sunlight would come down and strike a light beam on the wall of the galleries. And he said, I can't have that. We can't have that beam of light moving up over pieces of art. So I just simply got a drawing, a large-scale drawing of the reflectors, and with a straight edge, figured out by using the edge of the skylight opening and everything else, the width of this little piece of aluminum put in there.
And in this shot, you can also see the light track supporting the Edison Price out of New York. Fixtures were selected for the lighting. There's tracks on both sides of the diffuser here, and then also under the soffit as well. You can see also at the end too, as Frank talked about, the difference in the beams of the cycloids at the end, and then also the lunette glass. Here, this is pouring the floor of the mezzanine. Again, that would have probably been pumped if it was built during current days. This, was if you go up into the mezzanine now after the slab's poured, you get a real close look at the cycloid vault and the diffuser and the skylights as well.
Yeah, if you recall being in the main floor of the museum, where the bookstore is, there's a whole solid wall of oak, and back of that is the library, or was the library. Still the library?
No, the library was moved.
Anyway, but this is directly above the library, and there's a very handsome little wood oak stair that Lou Kahn designed that goes from the main floor up to this floor of the upper gallery.
Here you can see on the end, this would be on the south end, travertine is being installed on the end of the vaults there. And I found a number that says that there was 1 million pounds of travertine, 17 boatloads that came from 20 miles north of Rome.
Bagni di Tivoli.
Yeah. And
I think it's one of the world's largest quarries for travertine.
which has been fully depleted.
This is a photograph of the very interesting and unusual little fountain that Lou Kahn designed for one of the open courtyards. And when I saw the first drawings of that, Kahn's office, whoever drew it, had this all made out of one solid, huge piece of travertine. And I realized that was going to cost an astronomical amount of money. So I changed the detailing to where it's actually built out of pieces of travertine, but it has exactly the same final appearance.
And in the courtyards here, the travertine has, the joints are open, and the water, when it rains and stuff, flows through those cracks and into a drain that runs out then down into the storm drain. But, it's a way of getting the water out of that courtyard.
Might mention, go back to that, Simon, I hadn't thought of this for a long time, but if you see that trellis up above that courtyard, it's marine sailboat hardware, stainless steel cables and turnbuckles and whatnot. And I've got the late Dr. Hub Isaacs, who was a great sailor and a great, I think he sold marine hardware out of Fort Worth Boat Club, but he helped design and install that grid system of stainless cables.
And back in the early 70s to shade the courtyard during the summertime when it gets rather hot out there. We would put, we had sailcloths made that went over, tied down at the bottom where the hardware that Frank's talking about. We'd tie off there, and then they would go up over some cables in the shape of the cycloid. Well, we had that over the south court and then the north court as well. And here's the north court showing there. We spent a lot of time going out there trying to hang on to those sailcloths as they were sailing off in heavy windstorms. So eventually we got away from that and you know, just hope that the trees or the wisteria and the roses grow over those to keep it cooler out there. Here, the north court, you can see, and originally there was a mullion through the middle of this area here. The glass was all the same all around the sides, and Dr. Brown didn't like the idea that that mullion cut through the Mael sculpture, and so early on we went in there and
At the time the building was built, there was not a manufacturer that made a double glass pane that big. But as time evolved, it was possible to remove the mullion and put in a single double glazed pane.
Yeah, we built one originally, two pieces of glass and some silica gel in between it. And eventually they didn't, the glass people didn't get it sealed off good, and we had a streak down in the middle of it. And kind of hard to get in there to clean it. And then we did eventually, as Frank said, have a unit made that was sealed up and installed. Here is the picture of the east or the west lobby showing the stairway, and I wanted to show this because of the millwork here, and Frank mentioned it earlier, of the cabinets for the bookstore and then also the entrance to the library and stuff. Robert Shaw Manufacturing did all of the white oak for the trim and for the cabinets and stuff, and I think there was some 30,000 square feet of white oak. And I just found out just recently here when Frank and I started working on this program that Robert Shaw passed away March 1st. And we have continued to do business with Robert Shaw Manufacturing through the years, and actually have had them build a lot of things for us, from display cases and things. Latest was Balenciaga cases were built by Robert Shaw Manufacturing. So. Also here you can see the handrails for the stairways. Originally they were only on the east side, and these are made out of stainless steel, and kind of a Kahn specifically designed this shape, I believe, didn't he, Frank?
Very, very unusual shape. We could find only one fabricator in the country, at least in the state of Texas, the Offenhauser Company in Houston, that was able to form that, and to get the desired satin finish to it, it was blasted with pecan shells.
And we had, in the early 80s, had issue with people falling on the steps, and we went in and added the railings on the other side. We actually took all of the railings down and sent the old ones down to Offenhauser in Houston, and they made the new ones exactly, and they look identical to the old ones. And we actually had the old ones reblasted with the pecan hulls so they would all match once we got them installed. And then also down at the east entrance landing here, you can see some things that we added for safety reasons, where people were having trouble with the steps coming off of the landing onto the east entrance area. Okay. Here's Lou Kahn admiring his work in the west entrance.
You're going to say what he observed?
Yeah, I can do that. This about the building.
About the porticos.
Porticos, yeah. The comment he made about these porticos was that, let's see, where is it here so that I get it right. You know what is so wonderful about these porches? They're so unnecessary. This is the control center, or was a control center back in '72 when we opened. This was called Tab 1000. It had all the security and mechanical and electrical controls. Tab 1000 stood for Tim and Brownie. Tim Thomas Electronics, was a major designer in this. Kahn wanted things in here like the plexiglass where you could see through it and see where the wires went to, or see where the copper tubing went. E.B. Brown, of course, he was involved with it too, in terms of the operation and the security. And this was a status board that showed all of the light circuits on the floor plan. You could go in and dial up a 3-digit number, turn the lights off and on. And back in '72, that was pretty high tech. Now, all of this can be done off of iPhone almost, or all computer driven digitally now. The security system was all here in this status board. All of the doors, if you closed them up at night, and somebody opened a door, you'd get a red triangle that would show up of an open door, and you'd get an alarm, and that'd be flashing, so it's real easy to see where the doors were open. And then also there were overrides for the thermostats here in each room. There was about 83 zones, and you could adjust the temperature 2 degrees either direction, all pneumatically, now done digitally. So. And then security-wise, or closed circuit camera-wise, we had 6 cameras back then. Now I think we have well over 60-something. So
Most building contractors today, that is those who are doing major projects, have a scheduling system that involves what's called a critical path method. And the critical path method, if it had been made for the Kahn Kimbell building, would have been right through the drinking fountains. This was the last design element that came from Lou Kahn's office, this drawing, copy of this drawing. And you can see that Lou Kahn hated to use anything that was standard, so instead of having a standard drinking fountain, he designed this. And then the next slide shows how it was actually built. It's a very handsome thing, and some companies have developed drinking fountains that look somewhat like this. But anyway, if the critical path was shown for this building, it would go right through that drinking fountain.
finished product, you can see the cycloids, the porticos. One of the beauties of the porticos is that you see the basic structure of the cycloid. Kahn said you could knock out all of the travertine and the glass. Concrete is the only thing structural. So here you see the 100-foot span held up only by the two-foot square columns at the ends. The concrete or the travertine and glass is just filler. The reflecting pools here, Kahn wanted a quiet pool, and then that would flow over the edge into the lower pool. Another shot of one of the porticos looking straight down that. Then an aerial shot showing the building here.
And also the piano building where we are.
Well, piano building's not there. This,
Oh,
got
I'm
the
sorry.
modern
I'm sorry,
here,
this is modern.
and I don't remember what date this was, but yeah, the
Right,
piano
right.
building would be out here in this area.
Right.
One of the other things that we did over the years is in the pavers that were installed in the car parking area haven't held up very well over time, and we were constantly changing it out. These are the original pavers here that show the brick pavers, and they're 6 by 6, 1 inches thick. We had to do a lot of repair work on those and replace them. And in 2012, we were working on a restoration of the Kahn building for the opening of the piano pavilion, and Frank had suggested that we might want to consider changing these out.
Well, yes, originally Kahn wanted to use granite pavers such as you would see in old streets in European cities. But that was just proved to be impossible due to the carefully controlled budget that the Kimbell Art Foundation observed when the building was built. So it was found that we could find a true granite paver, although not like flagstones, but anyway, excuse me, not
Cobblestone.
cobblestones. And the next slide shows that. That's granite.
And that's, so we took that opportunity at Frank's suggestion and researched and found the Porfido granite from Italy that we replaced that with, and somewhat to go back with the intent of what Kahn had. So curious, you were talking about the cost and budget. I saw something in one of the things I was reading, maybe Tommy Seymour's article, and it was the building costs like $60 a square foot. Would you like to build something for that nowadays?
Tommy Seymour said the Kahn building was carefully wrought but expensively bought, even for $60 a foot.
And this is Kahn in the auditorium, a famous photograph of him with the light shining through, and you know, was he made the comment, and not here, but it was standing out in front of the west entrance of the building in an interview, and he said, "This building feels, and it's a good feeling, that I had nothing to do with it, that some other hand did it." I think that's, we have a couple of closing remarks now, so.
Yeah, in closing, please permit me to observe that although no one can diminish the creative architectural genius of Louis Kahn, Larry Speck, former dean of the School of Architecture at the University of Texas, concluded in an essay on the Kimbell Kahn building, and I quote, "Architecture is a team sport. I trust, therefore, we can all realize and agree that the Kimbell Kahn building would not be what it is without the talent, skills, devotion, and hard work of so many people that contribute to its design and construction." Thank you.
Then, going along with what Frank was saying, a quote from Tom Seymour, "In terms of quality, the building itself reflects the thought, perseverance, and persistence with which both designers and builders spin into it." I would like to give a special thank you to Frank for doing this lecture with me and for his help since the opening of the museum with all of the projects that he's assisted us on, which have been quite a few, and we've worked together for all these years. And it's been my great pleasure to have worked on the Kahn building during its construction in some small part, and my honor to have been given the responsibility to care for and maintain the building in various capacities over the 47 plus years. In doing so, I've tried to keep the building architecture as best possible pure to the original design. There have been some changes to a few areas that needed to be made for additional office space or for safety reasons, others for safety reasons, but otherwise, most of the spaces in the building have remained as they were designed and constructed. The Kahn building has worked exceedingly well for all these years, accommodating some 176 exhibitions, countless permanent collection changes, countless programs of various kinds, special events, and millions of visitors. It truly is a great building, both architecturally and operationally, a museum of the first class. At this time, we'd like to offer to respond to any questions you might have.
Sure. Were there any oh crap moments that you can recall in the construction?
Any old crap moments. There was, this was probably one, and I don't, in the slab, I told you there was post-tensioning cables. They were doing some work over, well, it would have been the southwest corner in the gallery slab, and somebody hit one of the post-tensioning cables and it popped up out of the slab, so I'm pretty sure that was one of those.
Yeah, Tommy Seymour and I figured out a way to restore that. We weren't able to get a hold of Dr. Commandant, so we just did it ourselves.
Just hearing Kahn say that last quote, feeling like working on this building, it felt like he wasn't involved. I just wonder, was working on this building for you two individually, did it feel personally different to you than other projects that you've worked on throughout the years? Did the Kahn building, I guess, how did it feel for you two working on it personally?
How did you feel about working on the building? Was it special?
Well, it's of course, it was an entirely different era between the building of the piano building and the Kahn building, and the techniques of construction were difficult. If you look at the farm work there, it was formed with steel strong back plywood instead of the through bolted farm ties that were conventional back at that time. So technologically, it's far more advanced.
And working on the job, it was a different construction process, and with the cycloids and the clear span of that and the post tensioning and all that, it was different. And at that point in time, I don't think we knew that it was as special as it is. And it was just a lot of things different about it. I mentioned the trim hammers that the carpenters used instead of the big heavy hammers. There was a sense about that there was more care given to the form work, and in just doing the polyurethane coating as well on it. And I mean, in the piano forms too, there was nowadays when we built it, there was a lot of work in cleaning the forms. They were put together under tents and stuff too. So some of the same stuff. There's a difference in the concrete between the Kahn building and this building. And if you have a chance, and Renzo called this concrete sexy concrete, and if you rub it and feel of it and then go over to the Kahn building, there's a difference. This is a smoother texture over here, but for 1972, that was pretty darn good concrete work over there. And another thing, with the forms were put together, there was tape applied at the joints to keep the water from running out of the forms and leaving stains on the other concrete. So in that sense, it was special.
I have a question about the vaults and the post-tensioning cabling in there. I've always found it really remarkable that those cables sit not in a flat plane. They're actually working on a curve, and one would expect that at a certain tension that those cables would just rip out of the skin of the vaults. So I was just curious, in estimation, with the columns relative to the rebar in the columns and that kind of thing, relative to the post-tension cable, about what percentage are those cables contributing to holding those vaults up?
I couldn't
What
understand most of it.
percentage of the
Yeah, I'm just curious because it seems like it would require so much force that they would actually end up ripping out of the shell of the vaults.
Well, there's, I showed you the picture of the wire mesh going down first, and then the post-tensioning cables between that and the wire mesh and the rebar on top of that. So, so far hasn't any pulled out. And the shell is only about, 5.5 inches thick. So, Well, and it's, after they pulled the pressure on the cables, it actually picked it up some off of the forms. And it's, I think Commandant said that the beams they're like beams that are pushing up to the top, and that's why the concrete beams every 10 foot was to keep the beam or the vaults from collapsing on themselves.
Okay.
Any others? Thank you very much for coming.